Welcome back, everyone. We are now on the last part of the lecture in graph sketching. Here, we are given the graph of the derivative of f, and from this graph, we want to sketch a possible graph of the original function. Let's look at the example. We are given here the graph of f prime. We assume that our function is continuous everywhere, and we want to sketch a possible graph of f. Before we proceed, let us remember that in our graph sketching, the table of signs of f prime and f double prime, or more importantly, the conclusions derived from this table, is what we need in order to sketch the graph and show its behavior on an interval, whether it's increasing or decreasing, or whether it's concave up or down. Now, in order to construct the table of signs, we need to determine first the critical numbers and possible points of inflections of our original function. Luckily, we can deduce these things in the graph of your f prime. How do we do that? Recall that we have critical numbers or possible points of inflections whenever the derivatives, so in this case f prime or f double prime, are 0 or undefined. Great. Let's start at when f prime equals 0. We look at the graph of f prime here, and we readily see that it is 0 at the points x equals -1, here, 0, and x equals 2. Okay? So it is 0 because it intersects the x-axis at those values of x. Now, let's find when is f prime does not exist. So clearly from the graph of f prime, it does not exist at x equals 0. Why? Because there is a discontinuity at x equals 0. Great. Now for the second derivative, it is 0 when x equals 1. So here, 0 when x equals 1. This is because the second derivative is the derivative of the first derivative. So recall that, whose graph is shown here. So to have a 0 derivative of f prime, that is f double prime equal to 0, we need to look at horizontal tangent line to the graph of your f prime. And we have a horizontal tangent line exactly at x equals 1. Nice. So moving on, we have f double prime of x does not exist again when x equals 0 because we have a discontinuity at x equals 0. Now gathering these facts, we now see that our critical numbers are -1, 2, and 0 from f prime, and our possible points of inflections are 0 and 1 from f double prime. Great! We're now ready to construct the table of signs of f prime and f double prime. So again, we will present the table of signs in a vertical manner, and we cut the real number line with the critical numbers and possible points of inflection. So since f is continuous everywhere, we do not have a vertical asymptote. Okay, so the intervals are as follows. So we have cut the interval, the real numbers from -1, 0, 1, and 2. So those are your critical numbers and possible points of inflections. So all we need to do now is to check the signs of f prime and the signs of f double prime, which we can deduce again from the graph of f prime. And then afterwards, we conclude things on the graph of your original function f. So let's start. For f prime and f double prime, so in here we are undefined. So because f prime is 0, x is -1 and 2, so 0 here, undefined at x equals 0. F double prime, undefined at x equals 0, 0 at x equals 1. Nice. So let's look at the intervals. From -infinity to -1, our f prime is positive. Why? So let's look at the graph. So it's from the left of negative 1. As you can see here, the graph of your f prime is above the x-axis. Since it is above the x-axis, we have positive values of f prime, and hence we have positive sign here. So it's actually like that. So you check the graph. If it's above the x-axis, it's positive. If it's below the x-axis, the value of your f prime is negative. So continuing with that concept, from negative 1 to 0, which is this part of the graph, which is below the x-axis, it is negative. So we have this negative. From 0 to 1, it's now above the x-axis, so it is positive there. So actually, from 0 to 2, all are above the x-axis, and therefore we have positive on those intervals. And then after 2 to positive infinity, it goes down to the x-axis, so we have negative. Okay, nice. So how about the table of signs for the second derivative? Now for the second derivative, our notion of increasing and decreasing will come up. Okay, so again, remember that if your function is increasing, its derivative is positive. If your function is decreasing, its derivative is negative. Okay? But our function in this graph, or we are given here, the function f prime. What's the derivative of f prime? It's f double prime. Hence, we only need to check whether your f prime is increasing or decreasing on that interval, and then we can deduce if its derivative, which is f double prime, is positive or negative. So let's look at an example. For the interval negative infinity to negative 1, or actually on this part, from negative infinity up to 0, as you can see here, part of the graph of f prime, it is decreasing from left to right, and hence its derivative, which is f double prime, must be negative. Hence we have on this interval from negative infinity to 0 to be negative. Great. How about from 0 to 1? So as you can see here, from 0 to 1, it increases, it goes up. So it is increasing, and hence we have a positive second derivative on the interval from 0 to 1. Now, after 1, so 1 to positive infinity, our f prime now decreases. So f prime decreasing means its derivative is negative. Nice. So therefore, the second derivative, f double prime, is negative. Great. Very nice. And because we have constructed now the table of signs for f prime and f double prime, we can now have the following conclusions. First, in this interval, negative infinity to negative 1, we are increasing concave down. And then we are decreasing concave down on the interval negative 1 to 0, negative, negative. On the interval 0 to 1, we are increasing concave up. Next, 1 to 2, we are increasing again concave down. And lastly, from 2 to infinity, decreasing concave down. Now, because we are increasing, decreasing, concavity does not change, but the increasing to decreasing, and hence we have a relative max at x equals negative 1. That's nice. Now, from here, decreasing to increasing, we have a relative mean, and also a possible a point of inflection, because we have changed from concave down to concave up. So at x equals 0, we have both a relative minimum and a point of inflection. Moving on, we have a POI, or point of inflection, at x equals 1 because of the change in concavity. And then we have a relative max at x equals 2 because of increasing change to decreasing. Very good. We have completed the table of signs of f prime and f double prime and the conclusions. We are now ready to graph a possible graph of your function f. So here is the possible graph of your f. So we have put the numbers -1, 0, 1, and 2 because those are relative max and critical numbers and points of inflections. So just like the previous example on graph sketching, we just check the interval, okay, and then use the conclusions to graph the function. Okay, so for example, at -1 to -infinity, we have this part. Why? Because from -1 to -infinity to -1, we are increasing and concave down. So we can only do that if we are going up and then concave down. So this is the part of the graph on the interval -infinity to -1. So you might wonder, this is just a possible graph of your function. Okay? So this part can be below the x-axis. Okay? But since we only want a possible graph, this can suffice. So we just graph it above the x-axis. But the main thing here is we need to preserve the behavior of increasing concave down. Nice. Next interval is from -1 to 0. So we should be decreasing and concave down. So decreasing on -1, concave down. So we get this part. Great. And then next one is we have 0 to 1. We need to be increasing and concave up. From 0 to 1, increasing, so going up, and then concave up. So we have this kind of part of the graph. Next is from 1 to 2, increasing, concave down. So we still go up, but now we want to be concave down. So from 1 to 2, the graph may look like this part. So again, from 1 to 2, the graph may look like this part. So it increases, but now change in concavity, concave down. Lastly, from 2 to positive infinity, so beyond 2, it should be decreasing. So we need to go down now, and then concave down as well. So we have this part. Did you get it? This is really, really nice. So it's from from f prime, we have derived a lot of information from the graph of f prime, and we are able to sketch a possible graph of the original function f. Great. That ends our lecture. Okay? Here are some exercises that you could answer and discuss with your discussion teacher. If you have any questions, do not hesitate. Do not hesitate to ask your teacher. Thank you for watching. Have a good day.